Hello, this is Ed Sullivan, editor of Building Operating Management Magazine. Thank you for attending today's webcast, Fire Safety and Fire Protection Systems. Our presenter today is Greg Barker. As Business Development Representative in the Special Hazards Fire Protection Group of Ahern Fire Protection, Greg supports Ahern offices throughout the Midwest from his base in Milwaukee. He has been in the fire protection industry since 1993 and joined Ahern in May of 2009. He has a BS in Technology, Construction Management from Pittsburgh State University. Greg specializes in fire suppression and detection solutions using non-water-based agents, fire extinguishing foams, and fine water mist systems to protect mission-critical equipment, processes, and properties. In addition, his most recent effort to educate facilities operators and fire officials involves combustible ducts and explosion risk mitigation through many presentations on the topic throughout the Midwest and nationally. Before we get started, I'd like to get a few housekeeping details out of the way. Today's presentation will be followed by a live question and answer session. To submit questions, please use the Q&A panel on the right-hand side of your screen and send your questions to all panelists. Our presenter will answer as many questions as time permits. Today's event will also include a multiple-choice interactive polling question. We ask that you do participate in this poll, as your input is very much appreciated. All participants will receive an email by the end of the day containing a link to download a PDF copy of today's presentation slides, as well as a certificate of attendance to today's event. The webcast will also be archived within 1 week at www.facilitiesnet.com/webcasts. And now, a brief word from our sponsor.
In order to evaluate your risk, Potter Corrosion Solutions offers a wide variety of corrosion testing options. Ranging from nitrogen generators to corrosion inhibitors, Potter offers a wide suite of products that can fit the needs of every customer. Potter draws on its history of sprinkler monitoring to develop the most robust corrosion monitoring solutions available today.
And with that, I'll turn it over to you, Greg.
Thanks, Ed. All right, so kind of jumping into our agenda here, and I'll get over to our first slide. I put together a little learning agenda, and I have 5 topics we're going to run through, and I won't claim to make anybody an expert, but what we will try to do is at least make you knowledgeable and aware that there are situations and equipment and different systems out there that can improve the fire protection within your facility. So with that, we'll move into our first topic. Our first topic is antifreeze and sprinkler systems. Protecting the system or creating a hazard. And a lot of people, some people do not even understand that they do have antifreeze sprinkler protection in their facility, but it is more common than you think. Freeze-protected sprinklers would typically be in docks and some of the areas that could see cold, but yet are not quite large enough that they would demand a what we call dry sprinkler or pre-action type sprinkler system. So it's a more cost-effective way to freeze protect. So what brought this to the attention of the NFPA? Well, the issue was an apartment fire that happened in Truckee, California. And in this particular incident, what happened was there was a pan fire, very simple, small fire on a range. The fire system worked, it went off. Unfortunately, it was a freeze-protected system with a high concentration of glycerin and water. Well, if you think about glycerin and water coming through a sprinkler system, some droplets become atomized. As that became atomized and hit that fire front on that pan, what actually happened was a fireball and an explosion. And it actually did blow some of the windows out of this facility and caused some injuries. So what the NFPA did was, through their committees, started to address this concern. And so this falls under the NFPA 13 Technical Committee, who started the investigation in May of 2010. And what they found is when they started looking through the fire records of the different fire departments, they also found a similar incident at a restaurant in Monmouth Beach, New Jersey. What happened in this case? Well, that was a patio heater that was a little too close to the overhang in a building, and it set off the exterior sprinklers, which were freeze protected for this canopy area. And when those hit the, when that discharge hit the heater, again, related or responded with a fire, and actually that antifreeze, being super atomized, created not really an explosion because it wasn't confined, but did aggravate the fire and cause a problem. Ultimately, the sprinkler systems do typically put these fires out. So what NFPA came up with in 2011 were these recommendations, that the antifreeze systems with glycerin be limited to a 48% concentration. In the propylene glycol-based mixes, a 38% concentration. And number 3, that factory premix solutions only be used to protect these different types of systems from freezing. Well, there's an issue with that. Those of us in the northern climates, what we've run into is that in some cases that's not sufficient freeze protection. And the reason for that is those concentrations really only get you down to a -16 if you're using glycerin, and a -3 degrees Fahrenheit if using glycol. Most recently, the NFPA did issue a TIA for NFPA 25, and this is a very current one, issued in September of 2012. And what we see in this one is that they've kind of backed off a little bit and said, okay, we know that these systems exist, but we also agree that freeze protecting these systems is important, because if they're frozen, they're of no value to anyone, because they definitely will not discharge and put a fire out. So by September 30th of 2022, all systems are supposed to be either replaced with a dry pipe system or changed out and have the listed antifreeze premixes put in. The concentrations of glycerin are limited to 50% by volume, and anything over 38%, which was in that previous recommendation, needs to be justified by an approved deterministic risk assessment. That's kind of hard to determine. Who's making that determination? The industry really hasn't defined that very well yet, but we'll see more on that as this progresses. The concentration of propylene glycol is 40%, and again, anything in excess of 30% needs a justification. And premixes are required when the products are newly introduced. I think the point here is that we would recommend that at least have an understanding of the systems and try to make sure you work with your sprinkler contractor to determine, how it is they're maintaining those, and make sure that there are not systems that have really high concentrations of the propylene glycol or the glycerin mix in those freeze-protected systems. So with that kind of wraps up our little update on freeze protection systems, and we'll move to our next piece, which is fire and smoke damper testing and maintenance. Fire and smoke damper testing and maintenance, it's a critical piece in some occupancies, and the occupancies that we typically see this enforced most regularly in are your hospitals and other care facilities. The relevant codes that we deal with in these types of testing and maintenance would be NFPA 80 for your fire doors, NFPA 90A for air conditioning installations and other ventilating systems, NFPA 92A, smoke control systems, and NFPA 105, which is smoke door assemblies and other openings of protective openings or opening protectives. In addition to those codes that I just went through, let me back up here, in addition to those applicable NFPA codes, if your area falls under the International Fire Code, in Section 703, it's not on this slide, but under Section 703, that code does refer you back to NFPA 80 and 105. So if you understand NFPA 80 and NFPA 105, you pretty well have it covered. So approving authorities, well, who enforces this? Who makes building operators and owners maintain these smoke and fire control systems? Well, one, state agencies and regulators. Two is the Joint Commission. That's relative to hospitals, local municipalities, and insurance companies. The reality is, in most cases, we do not see fire damper and smoke damper testing occurring in many facilities beyond the hospitals and care facilities. All right, so now we know what we have and what we're supposed to be doing. What it is, let's go through a couple quick definitions. What is a fire damper? Well, I'm not going to go through these real in depth, but you can always read them over later. Basically, a fire damper is a device to stop flame through just to stop flame from migrating from one portion of a building to another. A smoke damper, same thing, trying to stop smoke moving from one area of a facility to another. There's a combination fire and smoke damper, and those devices are really intended to stop both smoke and flame spread. A radiation damper, that would be a typical damper that would go through a fire-rated assembly. It really has no true airflow, but the damper is intended to close some kind of an opening in a rated floor or ceiling assembly. A volume control damper, well, that's pretty self-explanatory. It's controlling the flow of air. And then there's a term we need to understand, and that's dynamic versus a static system. A dynamic system is one where we're maintaining the movement of air within a system, and we're going to keep that air moving, but we're going to control it. A static system is really meant to stop the flow of air in the event of a fire. A few more definitions. We do have two different types of systems that we typically work with, one being a dedicated system, and that's dedicated strictly to smoke and fire control, and non-dedicated would be a multi-purpose dampering system where it's partly working with the HVAC system for air control in general, and also can be controlling the spread of smoke and flame. So what kind of testing and inspection are we looking at? What kind of intervals and what kind of detail should you be looking for when you're trying to get this service taken care of within your facility? Well, initially, NFPA 80 and 105 require 1 year in inspection and testing 1 year after installation. Then it moves to a 4-year interval after that initial year. And the only exception to that is hospitals, and hospitals do move to a 6-year interval for the testing and inspection. And when we say testing, we have some local authorities in our areas that require an annual visual inspection. It's really not a function test, but it's a visual inspection just to make sure that the damper is in place, and take a quick look at it to see really what it looks like. And we'll see that here in a minute with some of the pictures that I have. They're a little more self-explanatory of why this is an important function. There should be documentation and record keeping, and that's by code supposed to be available for your local authority, whichever one that might be. Access to the units, this is a problem we run into. We are also a mechanical contractor, and I've got to say that there are a lot of systems where those dampers are either trapped, as in you can't physically reach them, or two, the access ports were never cut in, and you can see the motor operator from the outside of the duct, but you can't get inside to take a look at it. And when we say take a look at it, you know, this is beyond just a little 6x6 access port cut in the duct. It should be big enough that, you know, a person can physically look inside of it and truly inspect the condition of that damper and verify that it's actually operating. So I guess the point of that is make sure they're sized properly. What to look for? Well, typically what you're looking for is interferences to operation, changes in airflow, and noise. And then in addition to that, verifying that there's full operation and sequencing. And when we do that, typically we're doing that in conjunction with the fire alarm provider, because most of these systems are integrated with the fire alarm so that the damper will control during a fire event. And there are some cases where the dampers actually have a test switch, and in that case the fire alarm contractor doesn't need to be working in unison with the fire alarm contractor, just a mechanical contractor by himself. So the point being, you know, there may be some coordination that you as the building operator has to take on to make sure that these two entities are working together to get this full function and inspection completed. We even have a few authorities in our area now that are requiring that on an annual basis, when those inspections, the visual inspections are done, that those dampers have a photograph taken, and this is more so in the hospital environment, that the vacuum off all the blades and make sure the dust and lint are off of them. And if you think about it, it could be an important factor. If you have a smoke or fire damper that isn't clean, there's a good chance that you're going to get some leakage during a fire event. So could be important. I'm going to bring up one point as we still are on this testing and inspection slide, and that's relative to the life safety of stairwell systems. A lot of stairwell systems have a positive pressurization system in them, and that's to allow occupants to evacuate and not be smoke not entering into that stairwell. When that happens, what we found in a lot of cases is the pressure sensors get out of calibration, and if you overpressurize a stairwell, what can actually happen is to a person trying to egress through that stairwell door, the pressure can actually make them feel like it's locked. And it's been proven that most people will not, you know, push too hard on the door because they're assuming that it is a locked condition. So this is just a copy of some of the typical test reports that our company provides. They're a pretty common test report that most HVAC contractors do use. And what these are doing is giving the technician a place to record his dampers, damper numbers, the fire dampers, the smoke dampers, the condition of them, and if there were any, you know, functional issues that need to be corrected. In addition to that, most companies will also tag those and number them. And the numbers on the tags and descriptions, again, reference back to that report. The idea being making it simple for the fire inspector and you as the building operator to understand, one, what needs to be fixed, and two, verification that it was actually tested. So what are some of the typical problems that we find on dampers, fire dampers and smoke dampers? Well, one of them, misalignment, things that have gotten cockeyed and just don't operate completely. 2, airflow restrictions. 3, I'll bring up the point that if there are defective components found during the inspection and testing, by code today, all damper parts have to be replaced with original OEM replacements. Otherwise, if your motor burns out, you can't just put a generic motor on it. It has to be the exact motor that was on that unit to begin with from the OEM. It can't be a third-party Grainger motor or some third-party site. So with that in mind, in some cases there are times when a unit just has to physically be replaced. It can't be rebuilt. There are some issues sometimes with recalls. Back in the 90s, there was a big issue with some of the motors seizing up, and that was due to the grease inside the units not having been functionally tested. The grease had dried out because the motor kind of gets hot, and over time that grease kind of became packed and tight and didn't allow that gear set to operate. So typical problems that we see in the field. run through a few pictures here just so you can kind of see what it is we're talking about. If you look right here, in this damper case, this is a real common issue. The cabling guy, they love to use these dampers as a place to pass wires through. So something for you to keep in mind is make sure that if you're hiring a cabling company, that you keep them under control and watch what they're doing, and make sure any good cabling company should not be using a fire damper or fire opening for their cable pass-throughs. Some others that we have here, we found pieces of wood. Some guys jammed a piece of wood in one of the dampers to hold it open so that it doesn't close, or the motor had failed and they just cock it open. If we take over here on this damper, you can see a zip tie put around that fire damper. It's not going to work very well with that zip tie in it. This picture over here is a picture of a typical access door. This one here is you really can't see it. These are photos from our technicians, and some of them are taken either with their small cameras or some of our flex cameras that we have. But this one in particular, the actual fire curtain damper in this duct is actually upside down. So unless the laws of gravity change, odds are that damper is never going to work in the event of a fire. It happens. That's what the inspection is there to prove. So with that, I'll jump that back over to you, Ed, and let you go through your poll question.
All right, Greg, thank you so much for the informative presentation so far, and thank you to all of our attendees who are joining us this afternoon. I'd like to take this opportunity to pose one polling question to you. If you direct your attention over to the right-hand side of the screen, you should see that pop up momentarily. And there we are. Our question today, simply, aside from Building Operating Management and Maintenance Solutions magazines, which other trade magazine do you read most often? 6 possible answers here. A, Facility Management Journal from IFMA. B, Buildings. C, BOMA. D, Building Services Management. E, Today's Facility Manager, or TFM. Or F, none of the above. Please do take a moment to determine which of those best represents you or your organization. Select and submit, and we'll be back to the presentation shortly. All right, and it looks like we're about ready to wrap up here. Thank you all for your participation in that poll. At this time, I'd also like to take the opportunity to remind you to utilize the Q&A panel also on the right-hand side of your screen to submit any questions you'd like Greg to address at the end of his prepared remarks this afternoon. And with that, I will turn the microphone back over to Greg for the remainder of the presentation.
All right, thanks. So moving on with our different topics here, I had a couple slides that we're going to wrap up the fire damper section here. But a couple of pieces that I do want to bring up is that typically a lot of fire inspectors during the initial commissioning of a building do like to see proof that the smoke control systems actually work. And it can be a pretty extensive test, depends on the type of facility. But what these pictures are here, this is one of a warehouse testing the actual smoke control system in that case. And this next one is actually at a hospital testing atrium area smoke control systems. Very important piece of the total fire function of the facility, and allows the occupants to safely evacuate and keep that smoke away from them as much as possible during that evacuation through the chosen routes. So with that, that kind of concludes our sections on the fire damper testing and inspection. And next we'll move into another technology piece, and this technology is high pressure water mist. It's not something that a lot of people are very familiar with, but it is becoming more prevalent, and as an alternative to what would have been the clean agents, systems like halons, carbon dioxide, and some of your newer FM200 and Acaro products. And as an alternative to pre-action sprinkler systems, typically all of these are used in what are called mission critical and high value spaces. So what is water mist? Well, it falls under the category of NFPA 750. We'll kind of run through some of these to at least make you aware of what the product is. And typically, most fire protection providers have access to a product line of fine water mist and can help guide you into specific applications and finding a solution. So what it really boils down to is water droplet size. A typical sprinkler system has a pretty good sized droplet in the 1 to 5 millimeter range. When we get into water mist, we actually break that into two categories. There's what's called low pressure water mist, and that's where we have kind of a mid-sized droplet in that 0.2 to 1 millimeter range, so still a pretty good sized drop. Or we have what are called the high pressure water mists, and the high pressure water mists actually are in your 0.025 to 0.2 millimeter range. So pretty small droplet, and we'll see the benefits of that small droplet here in a minute. If you were to be in a discharge of a typical sprinkler system, you'd definitely be a wet person very fast. In a fine high pressure water mist, what you'd actually feel like is like you were standing outside on a very foggy day, and you feel damp, your clothes are moist, but there's not water running off everywhere. It's not to that point. So how does fine water mist work, or how does water mist in general work? Well, to stop a fire, what we really need to do is try to remove some of these elements of the typical fire triangle: your oxygen, your heat, your fuel, and stop that chain reaction. Not much different than the way a sprinkler system works. A standard sprinkler really fights a fire by, 1, absorbing heat, and 2, is really cooling the objects nearby, and 3 is wetting. You can't beat the way a sprinkler wets Class A combustibles. So if you have a lot of Class A combustibles, like a lot of wood, plastics, any other Class A product, typically the solid fuels are better wetted by the large droplet of a traditional sprinkler system. How does a water mist system fight a fire? Well, it works in the same principle. It's just by making those droplets smaller, in a lot of cases we can actually suppress a fire, 1, with minimal water output, and 2, by having a smaller droplet. What we can actually do is that drop's going to flash to steam a lot faster, and it's going to absorb energy. By absorbing energy, we're taking away one of those elements. We're taking away that heat. We're attenuating it. Also, the fact that these small droplets have a tendency to float. They don't fall out of suspension as fast. What can actually happen is you kind of create an attenuation barrier to the potentially flammable objects around the fire source. So it just works in a little different method. 30–60% of the heat is actually withdrawn, and we create just enough steam that we actually can displace just a little bit of oxygen from that point of combustion. So very similar, but in some ways a little different than the sprinkler system. So in recap, again, the mechanisms by which fine water mist actually stops a fire: heat extraction, a little bit of oxygen displacement. That's a little bit different than a traditional sprinkler system, and radiant heat attenuation. And because the droplets of a traditional sprinkler system fall out of suspension rapidly, typically they don't do a very good job of attenuating heat. So where have we seen systems like this? You may have seen one if you've ever been on a cruise. The cruise ship industry was one of the first to take on these systems. If you think about what a cruise ship is and what it's really trying to be, it's a floating hotel. And you'd have to look really close to know that this was a fine water mist system, but the reality is those sprinkler heads or heads that you see in your rooms or in the hallways or other public areas probably wouldn't look a lot different to the typical person than a normal sprinkler head would. Now, why does the cruise industry want to use fine water mist? Well, it really boils down to revenue protection. If you think about that ship needs to be able to turn and go back on the next cruise in 7 days, 14 days. Fires happen. I mean, we've seen them. Fires happen on ships. If they were to happen in one of the guest rooms, potentially that guest room and any associated guest rooms, or maybe even that whole floor or the next floor below, could actually put that ship or a good block of that ship out of commission while they refurbish that space. If we can limit the damage by reducing the volume of water that it takes to put out a fire, or from an accidental discharge, which also happens on any kind of housing, what we can do is actually get that unit back into producing revenue for us. So it's really a revenue stream production. There have been some hotel operators that have also moved to this. Not as often. We've seen a little bit of it in Europe, not as much in the U.S. Where are some other areas we've seen fine water mist used? Well, one of them in particular, data centers, very large data centers. In most cases, the large data center operators have moved away from the clean agent gases due to the costs, and these large data halls have been traditionally protected with a pre-action double interlock sprinkler system. And if we move it to a fine water mist system, the odds of the large water cleanup or water damage potentially to nearby objects is limited. So if we discharge the fine water mist in this space as a pre-action, in most cases we're going to stop the fire or suppress it with a very minimal amount of water. The droplet size is so small in most of the high pressure systems that it's actually non-conductive up to a certain voltage. So it can be very safe around electrical environments. Some extensive testing has been done by the military for machine space and electronic protection, and there are test results out there that you can find if you look at some of the Navy testing. Some other areas that we see fine water mist being used where typically other types of fire suppression would be used in the past, spaces like generator rooms over here, the generator space that we look at, or in machinery spaces. And in the past, a lot of those types of rooms would have been protected by carbon dioxide or just traditional sprinkler. And people are trying to move away from carbon dioxide fire protection in potentially manned areas because of the life safety issues of carbon dioxide being an asphyxiant. So that wraps up our piece on fine water mist. Obviously, we're not making you an expert in it again, but just making you aware. And at the end of the presentation, I will give out my email address in case anybody has some questions. They can feel free to contact me, or like I said before, most fire sprinkler or fire protection companies do have these types of systems, and I'm sure would be happy to help you. So with that, we'll move into our next item. And the next component we're going to talk about is some, again, new technology. And in this case, we're looking at video fire detection systems. So we're going to take an intro to video imaging detection. Reality, well, my opinion is you better smile a lot because you're probably on camera more than you know. And the theory behind this is, how do we take the image of a typical video camera, which cameras are everywhere today, and use that image to replace a person having to sit there and analyze those video images on a recurring basis. Where is it currently used? Well, we're seeing it in manufacturing. I'm sure you've read some things about facial recognition with photos on the internet, inventory management, product identification, and the piece that we're most interested in is how to detect fire by using intelligence within the video image. Well, if we look back on the types of areas that would probably be best suited to the video imaging fire detection, we have some problems, some areas that we know fire is difficult to detect, or detect early enough that we can actually respond manually with a fire extinguisher and deal with it, or just stop it through a fire response by a fire department early enough that we can limit damage. Again, limit damage, maintain revenue. So conventional detection just doesn't work too well in areas with really high ceilings. We have this thing called stratification. Smoke gets cold, quits rising up. It takes a lot of smoke to let it go up into a very high bay because of that difference in temperature. And when it does stratify, it never gets up to the detectors that are way up at a 50-foot ceiling, say as in an atrium, hotel atrium, or a school atrium, or a typical assembly facility like a soccer stadium or basketball arena. Sprinkler systems, well, what are those there for? Probably just mainly to protect the building, you know, to retain the building and maintain safe path of egress during an evacuation. We also have a couple other things that we want to try to do, and that's give more information to our first responders, the fire department, and it would in some cases be nice to know if a fire started, how did it start? Well, there's ways to do that through the intelligence of using a video camera image with some analytics built into it. So what several manufacturers have actually put together is systems where electronically you can filter the light. And this is an image that we're looking at here of what one of these typical cameras is filtering out. And if you look at it, you see some black areas up here in the top, and those are actually the lights. And so what it's doing is saying, hey, that's a pretty static image I see in those pixels, so disregard that. Let's block it. We'll call it a blocking. If we look at the image on the right, this is the actual camera feed image right here, and that's the actual small fire. So what we're really seeing in this case is an outline of the reflected light image that camera is actually seeing on the left, and the actual flame image on the right. In the case of smoke, well, what we're actually looking at in this case is what we call an aging, or an aging analytics of the actual smoke. How long has that smoke been seen by each pixel? And the different colors that you're seeing here are the associated timelines. Otherwise, if the analytics say, hey, I've seen that smoke for 8 seconds, it turns all of that area or those pixels blue in its recording, and the orange means a little bit newer smoke, and so on down the line. So going back to why do we need analytics, and what does it provide for us that our traditional fire and smoke systems don't provide today? Well, nothing beats a person's eyes taking a look at an image or physically walking around looking for signs of a fire. Trouble is, not everybody's awake. And if they're not awake, well, sometimes it's a little bit hard to sense a fire until you either feel it or the smoke wakes you up. And if the guard isn't actually awake, the video image is absolutely useless. So it can be very mundane sitting there looking at a video screen for hours. Thus the reason a lot of analytics are starting to be built into cameras. It assists the person and can alert them of a change to that field of vision of that camera. Now the camera actually takes control and becomes self-sufficient. Otherwise, it can give you that information instead of you having to try to keep your eyes trained on it. So how do we do that? Well, you take electronic algorithms and you write those algorithms to simulate what a person's eye does, and then you train it. And if you train it through actual real fires, you can actually create a stored algorithm actually on board on the camera that can take all those images, process them millions of times per second, and analyze all those pixels for evidence of change within that pixel. Once you understand what's changed, then it's just a matter of analyzing what that pixel saw: smoke, flame, motion. In the case of facial recognition, if there was a combined camera with that, actually being able to pick out characteristics of an individual. So this is a typical layout of what the system is doing. It's a camera. It takes a digitized image. It processes it through different channels, looking at red and blue. If we take that, we can assimilate that into a flame. We can run that through the logic processor and ultimately take an output in some kind of a signal format. Typical system architecture looks very, very normal to a normal fire alarm system with one other component. If you take a look up here in this area, what we actually have is the traditional video recording architecture. If we take a look down in this section, what we actually have is the traditional fire alarm architecture. By combining the two of those, we can gain the best of both worlds. And people say, well, why do we have to have both? I can get my information from the video architecture by using the analytics built in. Why do I need the fire alarm piece? To be truly UL tested and meet the NFPA intent of NFPA 72, the systems have to be, one, be able to be battery backed up, and two, be fail-safe. Otherwise, if part of the system fails, we need to know that. Well, the only way to do that is to actually have onboard analytics within the camera, so within the camera body, and monitor contacts on the back of each camera with a traditional fire alarm input module. That becomes our UL-listed, NFPA-compliant fire alarm input device. And video smoke detection is covered under NFPA 72. This portion up here, not covered under NFPA 72, but this is where some of the really neat stuff happens, like recording and digitizing and sending images out to your smartphone. So as a system, it can be a real benefit to the building operator. And this is a typical fire detection scenario like I was talking about. Fire happens, camera picks it up, the information comes up in the graphical format. It can send you an email image of what that camera just saw, the one that went into alarm. If you have a campus-wide facility, you could even get that information to your campus-wide fire department so they can see what it is they're responding to. And through the traditional means, we're actually going to get a fire response through the normal dial-out procedure also. So that kind of wraps up our section on video smoke detection, video smoke and fire detection. And there are several manufacturers that make these systems. And again, if you talk to most fire alarm contractors, they have access to one of these brands of systems and would be happy to give you more details on them. So with that, we will move into our last section, which is corrosion and sprinkler piping. And corrosion and sprinkler piping has been a known issue for quite a few years. Initially, everybody thought most corrosion was microbes or microbiologically influenced corrosion. Between 94 and 2000, FM tested 155 different failed sprinkler systems, and they found that evidence of MIC, or the microbes eating the actual pipe, in about 40% of the cases. The other 60% were caused by general corrosion, which is due to oxygen within the water in the pipe. So everybody says, well, what does that mean to me? where do I have these issues? Well, it can be in both wet sprinkler and dry sprinkler systems, and we'll see that in a minute. But if we kind of look back on, let's get you up to speed on what is MIC, what is microbiologically influenced corrosion. Basically, it's kind of a slime or bacteria or fungi that can either be oxygen-loving or actually operate in a non-oxygen environment and will eventually create an atmosphere where it starts to consume the steel within the pipe. And if you look at this image here, what you can actually see is they build their own little, I guess I'm going to call it their little safe house here, right here. And the anaerobic or non-oxygen requiring microbes live inside of that shell, and they continue to eat away at that steel within your sprinkler pipes. What that ends up causing for you, leaks, pinholes, systems that fail prematurely. We've actually seen these failures in systems in some cases that were 2 to 3 years old. And I think as an industry, we're starting to learn more about it. In some cases, not only the microbes, we're also starting to see it in pre-action and dry systems. And that can really baffle people in that they think, well, I don't have any water. It's pre-action or dry. How could I have anything eating away at my pipe in a pre-action or dry system? Well, the reality is pre-action and dry systems are never truly dry. There's always some kind of an air-water interface in those. There's a little bit of moisture left in. There is water inside the system from maybe some initial testing. Maybe you had a false actuation, put water in the pipe. If you didn't go and pull all the sprinkler heads out, well, there's probably a little bit of water down in the bottom of that piping. So unfortunately, most systems are never truly dry. I always like to say these pictures look like something from a bad horror movie. I don't want to open up a pipe and see one of those staring back at me. I have some fear of some Sigourney Weaver movie where something jumped out of a person, but it happens. These little nodules can actually are spots where corrosion has happened. In time, it will breach the surface of the pipe and you will get a leak. So can you eliminate all the moisture in a dry pipe system? Well, that's probably not possible. So we're still going to get some, if you're just putting air in a system, traditional compressed air, even with a dryer, there's a good chance that every time you put a little more air in that system, that you're going to induce a little more or introduce a little more moisture into that. And as it condenses in that pipe, it's going to create water. And you can see within some of these pipes, some of the dry line interfaces, you can see where the water is actually kind of set in the bottom of it, down here at the bottom. Nothing up in the top. Nice clean pipe in the top, but corrosion in the bottom. So you say, well, galvanized, I've got galvanized pipe. Galvanizing protects my pipe. Well, that is true. It does help slow the process. If you think about galvanizing, the reality is zinc is considered a sacrificial anode. And what it's there to do is slow the galvanic action and give that pipe some protection. The trouble is once that zinc is gone from the inside of the pipe, it can actually accelerate the corrosion because the zinc doesn't equally dissipate from the whole pipe. It's spotty. And once you create a breach in the zinc, that particular point is going to corrode that much faster. So we've actually seen systems where galvanized pipe in pre-action systems and dry systems has failed faster than traditional black pipe. The other thing to look out for are some of the thin wall pipes that were used more prevalently, and still in some cases today, that can cause those failures to happen in a rapid duration. So what can we do to avoid corrosion? Well, number one, make sure the systems are installed with heavy wall pipe if they're, number one, if they're pre-action or wet or dry systems. But try to stay with a Schedule 40 pipe. Some of the thin wall pipes can have a problem, and in some cases, you know, just not as much steel for that corrosion to work on. Keep moisture from the piping interior, and a very important piece here is to reduce oxygen in the pipe atmosphere. So how do we reduce oxygen in the pipe atmosphere? Well, there's a couple of different technologies, but the most prevalent one today is actually working with a nitrogen injection system. And we've had some very small systems where we used traditional bottled nitrogen with a regulator system to inject nitrogen in place of compressed air. But those are not very cost effective on a bigger system. Every sprinkler system that's dry or pre-action has a few leaks. Air leaks out, has to be made up. And over time, it's difficult to keep up with the change out of typical compressed air bottles. So what the industry has done is come up with systems that actually take and strip nitrogen from the normal compressed air stream. And there's two technologies that have been used to generate nitrogen. Some of them you've even seen potentially when you go get a set of tires today. They'll offer to fill your tires with nitrogen for quite a hefty fee in some cases. Depends on your tire shop. But what they're using is a very similar technology, just on a very small basis. And that's the typical membrane generation style, where you put compressed air through a filter, and due to the differences in the molecular size of those oxygen and nitrogen molecules, you can actually filter and separate the oxygen from the nitrogen and put that into some kind of a receiver to use in your sprinkler system or in fill tires. The other one is a pressure swing absorption system. In those cases, those are a little more extensive systems and haven't been used as much in the fire protection industry. So these are typical generators. This one over on the left is a nice small self-contained unit. You can see the air dryer down here, the compressor and tank, and up here are the other nitrogen controls. This unit is by our sponsor, Potter. There are several other companies that make these types of units for the fire protection industry. And over here, this is a larger system with multiple pre-action risers. And this one can be used to protect multiple risers within a facility and give you that corrosion protection and not use the traditional compressed air. So with that, I hope it was a good hour for you. I appreciate you joining us. I think we're going to move into some questions. If anybody has more information and they'd like to get a hold of me, my email address is gbarker, G-B-A-R-K-E-R, at Ahern, A-H-E-R-N-F-I-R-E, so ahernfire.com. So gbarker at ahernfire.com. Thanks, and I'll turn it back over to Ed for any questions.
Thanks, Greg. That was a very informative presentation, and we do have a number of questions from our audience, so we'll see how many we can get through. One question that came through: who is supposed to inspect fire damper systems?
Typically, there's two types. There are a couple of companies out there that are strictly what we call fire door, fire damper testing and inspection companies. They are kind of standalone, and that is their special niche. On the other side, there are traditional door companies, like rolling door companies, overhead garage door companies. A lot of them will have a division within them that tests fire doors, and most larger mechanical contractors will have what they call a balancing and commissioning group that will actually come in and do fire damper and fire stopping inspections.
Okay, great, thanks. how often are fire doors required to be inspected, and how do you determine if a fire door is required?
To find out if a fire door is required, you really want to refer back to NFPA 80, and it has to do with the fire-resistive construction of any particular area. So if you look at the International Building Code and the International Fire Code, which ultimately reference back to the NFPA requirements, in this case fire doors NFPA 80, you will find some of the fire-resistive construction and requirements for where those doors should be.
Okay, great, thanks. What is the code requirement for having a fire damper on the discharge ducting from an emergency generator's radiator? The ducting exhausts out the roof through one floor space.
You know, that's one I would have to look at. I guess right off the top of my head, I'll never say I know all the codes, but it's something if somebody wants to contact me, we could talk about it and probably look that up a little deeper. That's one of those that would require some specific research.
Okay, great. Another question here. You mentioned a pre-agent double interlock system. Can you describe that?
Sure. A pre-action double interlock is a type of sprinkler system where we have a detection system that works in conjunction with a sprinkler system, a traditional wet sprinkler system. The idea being, by having double interlock, what we're going to do is we want to avoid a false discharge of water. It takes two actions to get that sprinkler system to let water flow. First action being the detection system going into alarm, setting a panel into alarm. That gives the first action to the valve. The second action is a physically breaking or fusing of that sprinkler head, which releases the supervisory air that's within that pipe. Once that air is released, now we have both actions that will allow water to flow into the pipe and ultimately through the sprinkler head that has fused or opened. So it's not going to flow through, it's not going to flow out of every sprinkler head, only the one that popped open.
Okay, great. Thank you. Can a conventional sprinkler head, be replaced with a high mist head?
That's a good question. Actually, in most cases, no, and here's the reason for it. In a high-pressure water mist, we're looking at pressures that a traditional sprinkler piping network would not withstand. There are some lower pressure systems, but in most cases, I've got to say that, you know, it hasn't been as popular. Some of the what we call just traditional low pressure water mist systems, yeah, potentially could. High pressure, no. Most of those are compression type fitting with a small bore stainless steel tube. There are some what we call twin flow systems out there where we actually take a lower pressure of water and inject into it nitrogen at the actual head, but in most cases not just a nice clean retrofit.
Okay, great. Do fine water mist systems operate at high pressures that require supplemental pipes?
Yes, that would be the case. So in most cases what we're dealing with is a standalone piping system just for the high pressure water mist system. And then it depends on if it's a what we call twin flow or single flow. In some cases they're pumped systems where we pump that pressure up very high. In other cases we're pushing nitrogen behind that system to push it out of the piping network and nozzles at a very high pressure. So it is typically a separate piping system.
Okay, great, thanks. Question, what about polypiping? What are the concerns with that?
Polypiping, I guess I don't quite understand that one. The only types of fire systems that we would typically see any kind of plastic piping in are some of your residential type sprinkler systems where we're using a low flame spread or CPVC piping network. Typically some of the orange pipe plastic. Don't really ever see that in fine water mist, that's for sure. Couldn't take the pressure rating.
Okay, okay. Is epoxy coating the pipes a good solution to corrosion? You
know, potentially we have seen some because we're a plumbing contractor too, we do know that there are corrosion inhibitors that can be put on the inside of a pipe, some type of coatings. The problem is, to date, I don't know of any that have been through any UL testing. And with everything that relates to fire protection in any facility, in most cases, what you see is that all of the components have been UL listed, and to date, in my knowledge, I have no idea if any of those are through that UL testing process. Good idea, though.
Okay. Speaking of UL, is there a UL listed or FM Global approved corrosion monitoring system? And if so, does corrosion monitoring replace the NFPA 25 5-year internal inspection on wet sprinklers?
You know, there are some corrosion monitoring systems. I think Potter has one. I think it's really a discussion that has to happen with I guess my depth of knowledge on the actual corrosion monitoring systems is not that great. So I would like to say probably defer that to Potter or one of the other manufacturers that do make the actual components.
Okay. What precautions and types of piping are recommended to cost-effectively protect buried fire protection piping? Any thoughts on that question?
Oh, underground. So typically, a lot of underground fire protection piping, we don't see as big a corrosion issue in that, but it does happen in underground piping. Unfortunately, not a whole lot of solutions in most of your underground systems, so can be difficult to corrosion protect underground.
Okay. What pressure does a fine mist operate at?
It can operate anywhere from about 600 psi all the way up to about 1200 psi, so they can be pretty high pressure systems. Some of the actual pumping units that these systems use look very similar to the types of pumps that would be used on high pressure water spray systems like pressure washers.
Okay, all right. What are the implications with using Schedule 40 versus Schedule 10 piping?
Again, when we get back to Schedule 40 versus Schedule 10 and the theory of corrosion, the idea being how much more material can you give whatever is causing the corrosion to chew on? If we want to really simplify it, how much more material can you give it to eat before it actually causes a problem with the pipe? If you're just going to leave it in there with no other form of protection like nitrogen or chemical MIC protection. So it's really just a matter of more material equals more time.
Okay, okay, great. Okay, here's a question about what methods can you use to protect your pipes if you have a wet system that is integrated with a perimeter HVAC heat pump system?
That's an interesting one. I guess I haven't run into one of those kind of systems, so that would be interesting. You could probably still use some nitrogen injection within the water. There are systems that can actually, as long as it's not a water that's being continually made up, otherwise more and more water being put into the system. Otherwise, it wouldn't work with a combination potable water, fire sprinkler water system, because you'd be changing out your water faster than that nitrogen system could make up or reduce the oxygen content within that wet pipe. So just not real familiar with that type of combined system.
All right, great. What's the NFPA requirement for inspecting dry systems for corrosion?
Dry systems on corrosion, right off the top of my head, I'd say I don't remember what that timeline is. Sorry about that. I don't have an answer to that one.
That's all right. You can't. I don't think anybody can memorize all the code requirements.
I try, but I've learned you have to just open the book a lot.
Right. Well, another code requirement is annual testing on a smoke exhaust system required, or is it every 4 years?
It's actually every 4 years. So it's at the end of the 1 year from the date the building was occupied. It has to be tested, and then every 4 years after that. So it's really kind of becomes a 5-year interval in the beginning, and then every 4 years unless it's a hospital, and then we're looking at a 6-year interval.
Okay, and speaking of that, here's a sort of a comment question. Have you discussed with hospital customers the concept to have you come in once a year and conduct the first year's inspection and then 1/6 of the existing dampers?
You know, we have not, and I think that's in our particular jurisdiction that I work in. They typically like to see that done as a group. Otherwise, they want the whole thing done at once. There are systems where I'm sure some local authorities say, yeah, as long as you're doing them on that recurring rolling basis, that's adequate also. Ultimately, I guess in the end, it does accomplish the same thing. So it would depend on your local authority.
Okay, great. And I think that this question goes back to the water mist systems. Can you add a booster pump to cover a data room only and not update the whole system?
In most cases, no, because you can't, the piping and the fittings in most of those systems are not adequate to take that additional pressure required by the system.
Okay. And members of the audience, if you have any other questions, now is the time to submit them. One more question here. As a C of F holder for supervision and inspection of fire alarm systems, would that qualify me to inspect the dampers?
It would. Potentially anybody can inspect them. I guess the reality is if the authority having jurisdiction in this particular occupancy allows that particular inspector, or if they're, whatever credentials they have, then sure, there's no reason why not. The issue may be whether repairs can be done and whether they're qualified for the repairs and the subsequent inspection and testing that goes along after that's been repaired. So it really depends on the local authority again, as in most things with fire protection.
Okay, and we have a follow-up question here concerning the data room example. What if you updated the piping in the data room, then can you add the booster pump?
Yes, if you replaced your existing piping, but it would not be a traditional booster pump per se. These pumps do have to be listed as a system by UL and FM, and in most cases fire tested. So typically the pump is going to be from a manufacturer that has a system approach to the whole water mist solution. And most of your major manufacturers have those systems, whether it's Fike, Fenwal, Kidde, Viking, Victaulic. They all have a system out there. Minimax, Marioff, High Fog, they all have a system out there that is considered a water mist system of some type. Each of them has their benefits, and each of them has different cost structure associated with it.
Okay, all right. A generally accepted life expectancy for a wet pipe sprinkler system?
Well, in the past, we wanted to say they were 100-year systems. More recently, through either changes in water in different municipalities or differences in how pipe is manufactured today, can actually, we've seen systems that have been started corroding within 3 years in some even warehouse and retail store environments. So, they should be 50-year systems, but there seems to be some issues that are causing these systems to fail prematurely.
Okay. One or two more questions here. Can you elaborate about commissioning requirements as they relate to fire protection systems? What should be included as part of the process?
Commissioning, that's a pretty broad topic, so there's a lot of things associated with commissioning, but it would kind of depend. Each NFPA code section, whether it's NFPA 13 for sprinklers, or 2001 for clean agent systems, or NFPA 750 for the fine water mist, or any other type of system, whether it's detection. Each code section has its own commissioning procedures that should be followed, and the best way I can say it is to pop open a section of code and go to the section called Testing and Commissioning and read through it and make sure that whatever contractor you're hiring is following those steps and has adequate paperwork to back it up and protect you after it's done.
Okay, one last question. Can you convert an existing dry system with air makeup to a nitrogen system?
Yes, and that's the whole goal of it, is to change out that air makeup system to the nitrogen system and get rid of that typical air stream that can have moisture in it and has a high oxygen content. By pushing that into that dry system, you're going to, one, extend the life of the system, and two, continue with the traditional air pressure within that sprinkler system that keeps the water back, and in most cases dry systems are used for freeze protection or as an alternative to antifreeze type freeze protection. So you bet it's a great way to keep the air in the system and not make the thing corrode any faster than you have to.
Okay, great. Well, Greg, thank you so much for your time today. It's been a very informative presentation. Members of the audience, thank you for your time today as well. This is Ed Sullivan, and that concludes today's webcast.